So my dear students, today we shall be discussing about the logarithmic differentiation. In our previous class, we have studied about the differentiation of exponential and logarithmic function. Differentiation of logarithmic function and logarithmic differentiation is different. In case of differentiation of a logarithmic function, we use the formula for the logarithm, like d by dx of log x is 1 by x, that we have to use, that we have learned in the previous class. But in case of logarithmic differentiation, we first apply the properties of logarithm. Then after applying the properties of logarithm, we get a function which will be quite easy for us to differentiate. Okay, now when we use the logarithmic differentiation, we use the logarithmic differentiation when the given function is a product of many functions and when the function is of the type function to the power function. So in this case, we apply first the logarithm, the properties of logarithm, then we differentiate the functions. So let us proceed how we do the logarithmic differentiation.
Logarithmic function means d by dx of a function which will be having log, okay, which will be having log. This is called differentiation of a logarithmic function. But the topic that we are going to discuss today, that is, as already I have told, it is what? Logarithmic differentiation. Now that logarithmic differentiation means we have to apply the properties of logarithm while differentiating a function. Before that, we have to know the properties of logarithm. Number one, log m n, m into n. This is in product, m into n, log m into n or log mn, which we know log m plus log n. Generally, these three and sometimes this 4 we apply as a property. Two functions we know that we can use the product rule. If it is like this, sine x into cos x, no problem, we can differentiate it by using the product rule, ddx of uv. But if it is product of many functions, sine x, cos x, suppose tan x, okay, there are three functions, even it can have another function ex. So you have seen that there are 4 functions involved in the given function. Suppose the function is fx and this function is product of 4 functions. So in this case, we cannot apply the product rule that we have learned in the earlier class. Second one, function, again the exponent is also a function, like this, x to the power x. X is a function, again this x is a function, the exponent is also a function. It is not like x square or x to the power 5. So in that case, we can apply ddx of x to the power n. That formula we can apply. But here we cannot apply the x to the power n form because it is not n, it is a function. Another example, sine x to the power cos x. Okay, so it is a function, sine x is a function, sine function, again the exponent is also a function, cos function. So when we get these types, the product of many functions or function to the power function, then we go for the logarithmic differentiation. And that logarithmic differentiation means what? First we have to apply the properties of logarithm, these 4. Okay, since it is in product form, so log mn, this type, log m plus log n, it can be extended. It can be extended like m and p. If I give here p, m and p, then log m plus log n plus log p. Okay, if I put another one, log m n p q, then log m plus log n plus log p plus log q, like that. Same in the case of division. Here I have written 2, but we can put many. Okay, so while solving the problems, that will be clear to you. Okay, let us go for the exercise 5.5, x cos 3x. So as you have seen, there are three functions which are in product form. So we have to apply the logarithmic differentiation. You just notice how I write. First we have to take it as y or some other variable. Let y equal to cos x, cos 2x, cos 3x. Then we have to take logarithm on both sides, taking logarithm. So this side will be log y and this will be log cos x, cos 2x, cos 3x, implies log y. Now you see the first property, m and p. That means log m means log cos x plus log cos 3x. Okay, now we are in a position to differentiate it. It becomes easier. So we will write differentiating. So d by dx log y. This side also d by dx 2x plus log cos 3x. The dx of log y is 1 by y log x. So 1 by cos x once d by dx of cos x plus 1 by cos 3x d by dx of cos 3x. The dx of cos x is minus sin x. We can put here minus sin x in the above, then below cos x. Again plus minus the dx of cos 2x is minus sin 2x. Even you can remember like this, the dx of sin x, you know cos x. The dx of sin mx type, sin mx means m cos mx. The dx of cos mx means minus m sin mx, like that, by cos 2x. Then minus plus cos 3x is minus 3 sin 3x by cos 3x is equal to 1 by y dy by dx equal to minus 3x. We have to cross multiply this y to that side. That means dy by dx will be here. Now one more step we have to write, that in place of y, that y that we have taken, we have to write here. Y means cos x, cos 2x, cos 3x, and then within bracket. So this is the final answer. So this is how we have applied the properties of logarithm while differentiating a function. And let y equal to, so first duty is to take logarithm. Taking, we get log y equal to now you see, first you have to convert this square root as a power. Square root, there is a square root, that means the whole power is how much? Half. Yes, the whole power is half. Square root is there, that means the whole power is half. That means you have to go for this log m to the power n. That means like this, power is half. Okay, that half will come here, half, then log this part. Next again half. Now you see it is in product form, but these are in, as a whole they are in question form. This total is n. So log m by n means log m minus log n. This will be log x minus 1 plus log x minus 2. They are in product form, so they will be in plus. Again the whole is in question form, below it is like a denominator, so all will be in minus log x minus 3 minus log x minus 4 minus log. suppose this part is not there, this part is not here, the denominator part is not here, that means log m into n. So what? Log m plus log n. Okay, then again for this, they are also in product form. So log x minus 3 plus log x minus 4 plus log x minus 5, but as they are in question form, so before that minus sign will come. All will be in plus as product, but minus will come, minus of bracket of log m plus log n plus log n, log p, but that minus will give us whole minus of this, minus of this, minus of this. Okay, log, suppose this is mn, this is pqr, this one minus log pqr. Okay, m by n, log m minus log n. Again this is in product form, so log m plus log n minus, they are also in product form, so it will be log p plus log q plus log r. Then it is log m plus log n minus log p minus log q minus log r. That is what I have written here. Understood now?
Yes, sir.
Yes, sir.
Yes,
So
sir.
this is how we got differentiating. Now we are in a position to differentiate it. Differentiating d dx of log d by dx of log y equal to d by dx of, so it will be always like 1 by y dy by dx. That half is like the constant k, half we can write outside of this. Now we will differentiate all the functions, this one, this one, this one, this one, this one. d dx of log of this means 1 by x minus 1. Okay, again if you differentiate this part, d by dx of x minus 1, you will get 1. No need to write. Then again here, d dx of this, d by dx of log x minus 2 is 1. No need to write. This is also 1 minus 1 by x minus 5. So d by dx equal to that y, let us cross multiply here, 1 by 2 y, then 1 by x minus 1 equal to half. Then what, that y we have to put y and this part. So this is the answer.
So students, we have seen how to use the logarithmic properties in case of finding a differentiation of a function, and I hope you understood it better, and we shall meet again in our next video. Thank you.